running out of time. So picking up where we left off, the acceleration we know is to the right at 0.6 meters per second squared. And so we know that the net force needs to be something other than 0, and it's equal to 35 newtons minus the force of kinetic friction. So we apply Newton's second law. Acceleration is equal to net force divided by mass. So 0.6 meters per second squared is equal to 35 newtons positive to the right minus the force of kinetic friction to the left divided by the mass of the block, which I've forgotten, it's 6 kilograms. And now I can solve for the force of kinetic friction. So 6 times 0.6, and the force of kinetic friction needs to be 31.4 newtons in order for it to accelerate at 0.6 meters per second squared. And so finally, I apply the equation for kinetic friction, mu sub k times normal force. So I'm saying that that 31.4 newtons of friction comes about because we have a coefficient of kinetic friction multiplied by the normal force, which is still 58.8 newtons. I divide both sides by 58.8, and I find that the coefficient of kinetic friction is 0.534. So it's not a whole bunch smaller than the coefficient of static friction, 0.595, but it's a bit smaller, 0.534, and that's consistent with what we understand about friction so far.